Welcome to week 4 of your GCSE Foundation Maths revision course. This week, we're building the foundation for everything that comes later. Algebra Basics. Algebra is the language of problem solving in maths. If you can simplify expressions, expand brackets, solve equations, and work with inequalities, you'll unlock a huge portion of the exam. In this lesson, we'll break algebra into clear, manageable steps. We'll cover expressions, equations, inequalities, substitution, and finish with exam-style questions and a quickfire recap. Let's get started. Chapter 1. Expressions. Collecting like terms. Collecting like terms is the foundation of algebra. You can only combine terms with the same variable and the same power. For example, 3x plus 5x is 8x, or 7a 2a is 5a. Meanwhile, 4x squared plus 3x 3y cannot be simplified because they are different variables or powers. Notes. Like terms equals same letter s, same power. Numbers without letters are constants. Expanding brackets single. Expanding brackets is also known as multiplying out. When in brackets, this is still complicated, so expanding brackets is also simplifying. The opposite of expanding brackets is factorizing. To expand a bracket, multiply everything inside by the term number or letter outside. For example, 3x plus 4 equals 3x plus 12. Notes. Multiply term by term. Watch out for negative signs. May also be referred to as multiplying out or simplifying. Expanding double brackets foil. Double brackets appear often in foundation papers. Simply put, when side by side, it means multiply. So two brackets mean multiply them by each other. Some like to use the mnemonic FOIL first. Outer, inner, last. You multiply the first term from the first bracket by the first term in the second bracket. Then also multiply the first term in the first bracket by the second term. Then do the same thing with the second term in the first bracket. For example, x plus 3, x plus 5 equals x squared plus 5x plus 3x plus 15 equals x squared plus 8x plus 15. Notes. Multiply each term in the first bracket by each term in the second. Combine like terms at the end. Factorizing single bracket. Factorizing is the opposite of expanding. You're putting the expression back into brackets. To do this, you need to find the HCF. This will go outside of the bracket. The terms divided by the HCF goes inside the bracket. For 6x plus 12, the HCF is 6. 6x divided by 6 gives x plus 12 divided by 6 gives plus 2. 4 squared values bring a variable out of the bracket. For example, 9y squared minus 6y equals 3y 3y2. Notes. Find the highest common factor. Divide each term by the HCF, factorizing double bracket quadratic equations. A trinomial is a good indication of being a double bracket factorization. For single bracket, it is generally binomials that return a single bracket. This is a multi-step solution, although for higher, there actually is a formula to solve these quadratic equations. Alternatively, the roots or x-intercepts are the solution for y equals 0. For factorization, the format for quadratics is x squared plus bx plus c. Factorizing, as we said, is returning to brackets, in this case, double brackets. If a equals 1, i.e., it just shows x squared without a coefficient. For example, x squared plus 9 by plus 18, you can immediately put an x in each bracket. This means the only outstanding thing is the second term in either bracket. This will be a number. To get this, we first find factor pairs of the constant c, the pair that add together to make the coefficient be. Here, it's 9. This go into the second positions in the brackets. For example, x squared plus 8x plus 15. X factor pairs for 15, 15, 1. And 35, 3, 5 equals 8. Middle coefficient equals 8. Therefore, plus 3 and 5, x plus 3x plus 5. Example 2x squared plus x minus 12. Factor pairs for minus 12 equals 12, 1, 26. And 34, all would be positive or negative. 4 minus 3 equals 1, middle coefficient equals 1. Therefore, minus 3 and plus 4. x2, 3x plus 4 notes. Remember, x squared plus bx plus c is quadratic. 2 brackets. If a equals 1, factor pairs for the c constant. Add 2 equal coefficient b. Chapter 2. Equations. Equalities, simple rule of thumb. Do you see an equal sign? If you do, it's an equality. Don't tell Donald. When solving equations, we essentially have a balanced scale, an equation. The equal sign splits to equal values on either side. Any change will only remain equal if you do this on both sides. One-step equations. Solving equations means finding the value of the unknown. Whatever you do to one side, do to the other. For example, x plus 7 equals 12. Subtract 7. Both sides, we get x equals 5. Example, 3x equals 18. Divide both sides by 3, x equals 6. Two-step equations. Two-step equations require two operations to isolate the variable. For example, 3x minus 4 equals 11. Add 4, we get 3x equals 15. Divide by 3, we have x equals 5. Equations with unknowns on both sides. To solve, we move all x terms to one side and numbers to the other. For example, 5x plus 2 equals 3x plus 10. Subtract 3x, we get 2x plus 2 equals 10. Subtract 2, it becomes 2x equals 8. Divide by 2, and finally it is x equals 4. Equations with brackets. Expand the bracket first, then solve. We get 4x equals 32, divide by 4, and x equals 8. Equations with fractions. Clear the fraction by multiplying both sides. For example, x3 plus 2 equals 7. Subtract 2 leaves, x3 equals 5, multiply by 3, the result, x equals 15. Chapter 3, Inequalities, Solving Inequalities. Inequalities work just like equations, except instead of equals, you have does not equal greater than, is less than or equal to, or is greater than, or equal to, or is greater than, or equal to, or is greater than, is grade better, or is less than or equal to 11 plus 4. And it's 3x is less than or equal to 15. Divide by 3, and finally, x is less than or equal to 5. Example to x plus 3 greater than x4 subtract x. We have x plus 3 greater than 4 subtract 3. We find that x greater than minus 7 representing inequalities on number lines. Inequalities can be shown on a number line. Depending on the range, different standard rules are used. Rules. Open circle is or closed circle means equals is less than or equal to or is greater than or equal to. Arrow shows direction. Chapter 4. Substitution. Substituting into expressions. Substitution means replacing the variable with a number. For example, area of triangle A dong yu B HB dong yu shir H dong yu lu A dong yu cheng shir cheng lu dong yu san shir. Exam style questions. Question 1. Expand and simplify. Expand 3x plus 4, 2x to 1. Worked solution, Q1, 3x plus 4 minus 2. x1 equals 3x plus 12, 2x plus 2 equals x plus 14. Question 2. Solve the equation, 4x minus 7 equals 2x plus 9. Worked solution, Q2, 4x minus 7 equals 2x plus 9, simplifies to 2x equals 2x plus 2x equals 2x plus equals 6 equals x, sickle x. Equus by sick apple it, would to be cuckle 6 canply in a beckle in it. Within a bit would to gifle a bipica call up a cold dot the wood in a kitten I we give I with I think what I could think what that if I would think what I would like I with the wall I the what the Question 3. Solve the inequality 5x plus 318. Worked solution, Q3, 5x 15, then x3. Question 4. Substitution. Evaluate 2a squared, 3a plus 1 when a equals minus 2. Worked solution, Q4. Evaluate 2a squared, 3a plus 1 when a equals minus 2. So 4 plus 6 plus 1 equals 15. Quickfire recap. Let's finish with a rapid recap. Pause the video if you want extra time. Questions E. Simplify. Tx da sen, x jan war r, expand, sikwar har, x jan sen, kor hui. 3 solve, 3x plus 2 equals 17.4. Solve 2x, 5 greater than 9.5. Evaluate x for x, when x equals 6. Answers. 1. Simplify. 7x plus 3x, minus 5 equals 10x minus 5. 2. Expand. 4 2x, 3 equals 8x. 12. 3. Expand. 3x 3x. 3x 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 4. 7x lex 7x sec x. Lex at x sec x x sec x x x x sec 1 x x sec 1 kin ak and kick kin sucks with that the guy with the with that with that fight with I will buy at like I with the fuck the like at my cup over I work off it fuck with I went to what was bad about that of what that the book whether the what So x greater than 7, 5. Evaluate x for x, when x equals 6.36 to 24 equals 12. Great work completing week 4. Algebra is the backbone of GCSE Maths, and everything you've learned today will help you with equations, graphs, formulae, and problem solving throughout the rest of the course. Next week, we'll move on to graphs, where we'll explore coordinates, gradients, linear graphs, quadratics, and more. See you in week 5. Oh, don't forget the liking, subbing, and all that.